Chapter 6 Test Review. Number 1, perform the indicated operation. So what you're looking for is, you notice this says plus, so all you're doing is adding the like terms. And in this case, this is kind of silly because I don't see any like terms, so there's nothing really to do other than just write them in order. If I was going to add the like terms, this is what I would have. It's not a very interesting problem because there aren't any like terms, but that's what it is. Next problem, you see division. So you take the g function divided by the f function. Next problem is a little bit more interesting. You're going to subtract, but I notice that there are some like terms this time. Those a terms are going to need to get combined. So you're taking f minus g, and so you take f minus g, and a lot of students will get tricked by this because you have to subtract the a squared and also subtract the 2a. So I like to think of it as distributive property. You're distributing the minus, so it's going to be subtract a squared and it's going to be subtract the 2a. You've got 3a minus 1 minus a squared minus 2a. Now I'll think about putting the like terms together. 3a minus 2a is a, but just write them in order. You've got negative a squared plus this a minus the 1. There you go. Number 4, this means composition. This does not mean multiplication, it means composition. You're going to take the f function and plug it into the g function. So I like to think of it this way. You're just going to plug the f function right in there for the variable. So the g function says 3 times something minus 3, but we are plugging in the other function, a minus 5. It's a distributive property, 3a minus 15 minus the 3, combine your like terms, 3a minus 18. The next problem is a multiplication problem. So we're going to take f times g, and it is a distributive property. That's going to be 12n squared plus 8n, and then another distributive, minus 9n minus 6. Remember, that is multiplication. I see some like terms here, 12n squared minus n minus 6. Number 6, state if the two functions are inverses. It's pretty obvious that they're not going to be inverses, but because there's nothing that's going to cancel out this 9. That's what inverse functions do, is they cancel each other out. But how you have to show this is you have to plug a function into the other function and see if all the numbers cancel out. Okay, so if I plug f into the g function says 20 plus 9 times something over 4. And so what I'm plugging in is that other function, 5x over 3. So that's kind of a big old mess, but let's see what happens. 3 cancels the 9, 3 goes in 3 times. So I have 20 plus 3 times 5x is 15x over 4. What you're looking for is all the numbers to cancel out, and you would be just equal to x. And since that does not happen, I can tell right now they're not. They're not inverses. They are not inverses. Thing that kind of stinks, though, is if that did work, if you did plug one into the other and get x, then technically you'd have to go the other way, and you'd have to plug this function in here and see if it also makes x. So if you're doing it this way, you have to show that plugging f into g gives you x, and also plugging g into f gives you x. It might be easier, though, to just find the inverse of a function. Find the inverse of a function. We've got a certain set of steps. Step 1, we're just going to write that as y. Step 2, we're going to switch x and y. Step 3, we're going to isolate the y. So solve for y. What I would do here is I would multiply both sides by 4. That's going to cancel out my fraction. I've got 4x equals negative 20 minus 7y. Notice I don't have to distribute that 4 because it canceled out. I'm going to, what are we trying to do? ISO the y. I'm going to add the 20 over. Now notice those are not like terms, so don't say 24x. They're not like terms. You're just going to have 4x plus 20 equals negative 7y. And then divide by the negative 7. We're trying to get y by itself. Okay, and now we've got it. We've got y equals 4x plus 20 over negative 7. And then the last thing we're supposed to do is replace that y with your function notation. Oops, this isn't f. This is a g. So we would go g inverse of x equals 4x plus 20 over negative 7. And there are other ways to write that. If you want to split it up and write it as two fractions, that's fine. 8 and 9, we're graphing functions. So what you need to know on this one is you need to know that a square root function looks like an eyebrow. It's kind of like a half of a parabola on its side. And so we still have the 1, 3, 5 pattern like in a parabola, except this one's going sideways. What we want to do first, though, is find that vertex. The way I look at it is look at what number makes this 0. You look at that expression and you try to zero it out, and negative 6 is going to produce 0. And what that does, when you find that 0, you're finding the starting point. You're finding the starting point of that eyebrow shape, okay? Think about an XY table if you want to. If you plugged in x was negative 6, you're getting 0. And so we've got the point negative 6, 0 as the first point of our eyebrow shape, of our radical function, okay? That's the first point. Now, what you could do if you want is you could plug in some more numbers, but I know I don't want to do that. I want to use this pattern. I know it's a 1, 3, 5. I know what the graph looks like. It's a square root. It's an eyebrow. So I'm going to go over 1 and up 1, over 3 and up 1, over 1, 2, 3, 4, 5 and up 1. That was there. Okay, don't be lazy and don't skip this step. Okay, I'm showing you a huge shortcut by not making you do a table. If you're not going to do my shortcut, then you have to do a table. Otherwise, you're not showing enough. I don't want to just see you put a dot and then this. That's not good enough. I need to see the dots, and I need to see that you did the 1, 3, 5 pattern, or I need to see that you did the table. I know which one I would do. So the next problem, number 9, again, we know it's a square root function, so we know it's this shape and it has the 1, 3, 5 pattern. We look for what makes 0, and that's negative 1. But then this time, if you plugged in negative 1, you still have this number over here. All that other stuff's 0, but 0 minus 4 is negative 4. So you can look at this as left 1 and down 4. So we go left 1 and down 4, and that's the start of our shape. We've got that 1, 3, 5 pattern, so go over 1 and over 3 and over 5. And there we go. Now again, if you're going to use 1, 3, 5, use 1, 3, 5. Otherwise, you've got to fill in this table. All right, now we're simplifying radicals. So simplifying radicals, the variable part's the easy part. If I do the square root of x to the 4th, that's going to be x squared, and square root of y second is y. Remember, you've got a root index of 2, and 2 goes into 4 twice, and 2 goes into 2 once. But you've got to break down the 112, and that's the hard part. So 2 goes in, what would that be? 112 divided by 2 is 56. Okay, 56. And divide that by 2, it's 28. And divide by 2, you get 14, and divide by 2, you get 7. Okay? So I see 2 to the 4th power times 7. And if I did a square root of that, we're looking at the second root. And it goes into 4 twice. And it doesn't go into this 1, so the 7 has to stay in. Okay, I've got 2 squared, which is 4 in the front there, and a square root of 7 in the back. 4x squared y times the square root of 7. Next one, 18. The fastest way to do an 18 is to split it into 9 and 2. Okay, you want to use 9 because you know the square root of 9 is 3. So other than that, you can look at the variables. It's a root index 2. 2 goes into 3 one time, so one of the b's comes out and one of the b's stays in. So we've got kind of a big old mess. Let's clean it up. I've got 4 times 3 is 12. And I've got another b that's outside, but then I've got a 2 and a b that's inside. 12b times the square root of 2b. Next problem, number 12. We know the square root of 100 is 10. And we know the square root of a to the 4th is a squared. We just have to multiply negative 8 in the front. Negative 8 times 10 is negative 80. A squared. Next one, cube root of 80. I can't do that one, so cube root of 80. Divide by 2, you get 40. Divide by 2, you get 20. Divide by 2, you get 10. Divide by 2, you get 5. So I see 2 to the 4th times 5, and I want to do a cube root of that. 3 goes into 4 one time with 1 left over. Don't forget it's a cube root, not a square root. 3 goes into 1. No, it doesn't, so that has to stay in. When you've got a 2 and a 5 inside, 2 times 5 is 10. There's a cube root of 10 left inside. But there's this 2 that's outside. And this 2 is going to get multiplied by the negative 9 and make negative 18. And so all that's left is you have to take the 3, do the variables. Maybe I should have done that first. 3 goes into this 9 3 times, so that means 3 of them come out. Negative 18 r to the 3rd times the cube root of 10. Okay, 14, we want to add some like terms, and we don't have any like terms, but we're going to be able to break down that 45. So 45 is square root of 9 times square root of 5, or 3 times the square root of 5. So if that's 3 times the square root of 5, times this 3, you have 9 square root of 5 right there, plus 2 square root of 5 minus square root of 2. You can combine the like terms. 9 square root of 5 plus 2 square root of 5 is 11 square root of 5 minus this square root of 2. Now do not do 5 minus 2 is 3. Those are not like terms. There's nothing we can do there. Number 15, we can break down the 12 into 4 and 3. Square root of 4, square root of 3. So that's going to give me negative 2 square root of 3. The 27 we can break down into 9 and 3. So that's going to be minus 3 square root of 3. If we look at our like terms now, we have this and this is minus 5 square root of 3. But then don't forget the plus 2 square root of 5. Those are not like terms. Do not add them. Next one, multiplication. 12 times 6 is 72. So we can say that's the square root of 72. But now we want to break that down. The best way to break down a 72 is 36 times 2. There are a couple of other ways, but you don't want to do like 9 and 8. If you did 9 and 8, that looks like it's going to be right. But the problem is that 8 still has a 4 inside of it. And so you don't want to break it down using the smaller numbers. You want to break it down using the biggest number you possibly can, 36. Square root of 36 is 6. You're going to get 6 times the square root of 2. 17, distributive property. Let's distribute. Remember, you can multiply those square roots, so you get -5 times the square root of 10, and distribute here, you're going to get plus square root of 15. There's nothing more we can really do. Those aren't like terms, you can't combine them. 15 and 10 don't break down. Number 18 is a distributive property problem, a double distributive. I'm going to distribute here, I get square root of 15 plus square root of 6. And then I distribute here, I get plus square root of 10 plus square root of 4. Only one of those numbers breaks down. Square root of 4 is 2. And so nothing else really happens. There's nothing else we can really do. We just say that we're going to add them together. Square root of 15 plus square root of 6 plus square root of 10 plus 2. All right, more recently we started talking about radical form and rational or exponential form. Remember, the denominator here is the root index, and the numerator is the power. Next one, exponential form. It's a root index 2. You know that when it's a square root. And when there's no exponent, it's basically just to the first power. And so we can say that's r to the 1/2 power. But just memorize and learn a square root is a 1/2 power. So then the next one, simplify. I think the best thing that you can do is change it to radical form first. That denominator is the root index. 16v to the 4th. We're taking the 4th root of that. And again, this numerator, if it's 1, you don't really have to do anything because, that doesn't do anything. So we want to take the 4th root of 16. So some of you might know that one. Divide by 2, you get 8. Divide by 2, you get 4. Divide by 2, you get 2. So that's 2 to the 4th. 2 to the 4th power. If we take the 4th root of 2 to the 4th, that's just going to be 2. And 4 goes into this 4 once. Nothing left over. We need to do on 22, we need to do the 3rd root of 216 in cubed. But then we're going to have to take that to the 2nd power. So the 3rd root of 216, again, some of you might know that one. Divide by 6, you get 36. Divide by 6, you get 6. That's 6 to the 3rd. The 3rd root of 6 to the 3rd is just going to be 6. The 3rd root, 3 goes into this 3 once, so we've got 6 in. But now we have to square it. 6 squared is 36. N squared is just n squared. Solve each equation. We want to isolate the radical, which is done, and then square both sides. I see 100 equals a minus 4. Let's just add the 4 over, try to isolate the variable, and you get a equals 104. Next one's a little bit harder because we've got an extra step. We want to isolate the radical first, so I'm going to add this 9 over first. I've got square root of 8x plus 9 equals 9. Once you have the radical isolated, square both sides. Square root squared cancels out. 8x plus 9 equals 81. I'm going to subtract this 9, so 8x equals 72. Divide by 8, and x equals 9. Last one, square root equals square root. We can just square both sides, and that completely goes away. 23 minus 2p equals 3p minus 27. If you've got variables on both sides, the easiest thing to do, the best thing I think to do, is to knock out the smaller variable. So I'm going to add 2p. 23 equals 5p minus 27. Add the 27 over, and that gives me 50 equals 5p. So divide by 5, p equals 10.